Hi everyone, so this is the first section in chapter 5. If you like to title your notes, chapter 5 is all about radical functions. In Algebra 2, we've worked with a lot of parent functions, so we started with quadratics, then we went to polynomials, we worked with cubic functions, and then last in chapter 4, we worked with rational functions. So now we're talking about radical functions, and we start with this introductory lesson about radical exponents, rational exponents, and roots, okay? So let's take a look at some vocab first. Some vocab we want to take a look at is this notation here. Before this lesson, you probably would have just seen this notation and said square root, right? And that's correct, but now we're going to look at it being called a few different names. So this is a square root symbol, like you would have thought. And that's fine because when there isn't a number here, which we've never seen before, when this is empty, we would read it as the square root. But when there is a number here, in this case, this number is called an index, is 4, the root changes. That's why this is an nth root. It can be any number. So I would read this as the 4th root. If it was a 3, I'd say the cubed root. A 5, the 5th root. But if there's nothing there, I would have read that all along, just like we've been doing, as the square root. The radical symbol, that's what this symbol would be called. And then this number underneath the radical is called a radicand. And I would read this whole thing all together as the 4th root of 81. So let's take a look at an example here. It says, what are all the real cube roots of 125? So this is how I would write the cube root of 125. My root means that I have to have a radical. My radicand is 125, and my index, I see cube, is a 3. Let's think about a side example here. If I told you to find the square root of 9, well, what is the square root of 9? You would tell me 3. How would I check this? You could say 3 times 3 equals 9, right? And why would I multiply 3 by itself 2 times, right? 3 times 3. I did it twice because it's a square root. So now I'm doing it 3 times because it's a cube root. So I need some number multiplied by itself 3 times to give me 125. What's that going to be? You can kind of just do trial and error on a calculator. That's going to be 5 times 5 times 5, right? The same thing multiplied by itself 3 times is going to give me 125. So the cube root, I could say, of 125 is 5. And that's it. Let's look at another one. Here it says, what are all of the real 4th roots of 16? So the first thing that's new here is we have to take this English and turn it into math, right? So I see the 4th root, my index is a 4, of 16, my radicand is 16. And then I have to think about it. My index is 4, so I need some number multiplied by itself 4 times to give me 16. What's it going to be? It's going to be 2. 2 times 2 times 2 times 2 gives me 16. The 4th root of 16 is 2. Okay? That's what this first example is about. Not too bad. The next example that we're going to look at, you're going to do these try-its in the practice section. We're going to look at rational exponents. So we just finished a whole chapter on rational functions. What type of number is a rational number? It's a fraction, right? A rational exponent is a fractional exponent. What happens when I have an exponent in my fraction? Oh, so many words here. One second. What happens if my exponent is a fraction? That's what this example is all about. And we have to learn this new rule, okay? What happens when my exponent is a fraction? And this is what it's going to be. I can always rewrite it as a radical, okay? These two things are the exact same thing when this is my exponent. What it does is it says that I can take my denominator and make it my index, and my numerator and make it the exponent of my radicand. It wasn't written there because it was a 1, right? And when I have a power of 1, it doesn't change the number. So that's what we're going to use to be simplifying some of these numbers here. Let's take a look at it written this way. When my exponent is a fraction, I can rewrite it using a radical. My denominator becomes the index, and my numerator becomes my exponent. Okay, so let's look at this first example. 16 to the 1/4. I rewrite it using this example. My denominator becomes my index, and my numerator is my exponent. And I want to rewrite it like this because now I know how to simplify this. Okay, I'm going to look at this, the 4th root of 16. The 4th root of 16, I just did. What is the 4th root of 16? That's 2. And then I have 2 to the 1 now, right? I can work with that exponent. 2 to the 1 is just 2. Okay? And my thought process with getting 2 is, remember this. What times itself 4 times is going to give me 16. So what we do is we simplify the radical first, and then we deal with the exponent. Let's look at another one. 27 to the 2/3. As soon as I see a fraction in my exponent, I don't like it. That's like horrible for my eyes. I want to rewrite it using a radical. I take my denominator and make it my index, and I take my numerator and make it the exponent. And then I work with the radical first. So I just do this, right? The cube root of 27, I need something multiplied by itself 3 times to get 27. What's that going to be? 3. So the cube root of 27 is 3, but that squared is still there. So now I can do 3 squared, 9. That's easy, okay? So 27 to the 2/3 is 9. Okay, rewriting it is the first step, and then working with the radical before the exponent is the next step. Okay, you're going to take a look at the try-its in the practice. And here's the next example that I think I'm going to do in the next video. So hop on to the next video to learn how to do some more simplifying with rational exponents.